Good morning and welcome back. In the last lecture, we talked about reflection of waves and we derived the expression for simple harmonic progressive wave. Let's move onwards. In simple harmonic motion, we have studied that when a particle is subjected to two SHMs simultaneously, when a particle is subjected to two SHMs simultaneously, then resultant displacement at that point is the vector sum of all the displacements. That is called composition of SHMs, isn't it? Same rule can be applied for waves, because wave is simple harmonic progressive wave. When the wave is generated, the particles of the medium, they are performing simple harmonic motion. Therefore, that principle that we used in SHM, composition of SHMs, it can be used for waves also. And here it is called superposition of waves. Superposition of waves. What is that superposition of waves? It says that when two or more waves arrive at a point of a medium simultaneously, if two or more waves arrive at a point of a medium simultaneously, then each wave produces its own displacement independent of the others. And the resultant displacement at that point is the vector sum of the displacements due to all the waves. Means what? Wave means disturbance. जेव्हा वेव एका पॉइंट वरती येते तर ती वेव काय करत असते? ती वेव पार्टिकल्सला डिस्पर्स करते, डिस्टर्ब करते, है ना? The wave disturbs the particle, means displaces the particles from their mean position. पार्टिकल्सला त्यांच्या mean positions वरून वेव काय करत असते? डिस्प्लेस करत असते. वेवचं काम आहे. आता समजा हे आहे अनडिस्टर्ब्ड मीडियम. What is this? Undisturbed medium. इथे वेव कोणतीही पोचलेली नाहीये. Now in this undisturbed medium, suppose this is a particle. This is particle of undisturbed medium. समजा या पार्टिकल वरती एक वेव जर आली, suppose if a wave arrives at this point, तर ती वेव या पार्टिकलला एवढं डिस्प्लेस करणार आहे वरती. किती डिस्प्लेस करणार? This much. It is going to displace the particle this much above. Okay. If the wave arrives at that point, okay, जर आली तर, आलेली नाहीये. जर वेव या पॉइंट वरती आली तर या पार्टिकलला एवढं काय करणार आहे? वरती डिस्प्लेस करणार आहे. In place of this wave, if another wave comes at that point, या वेवच्या जागी दुसरी एक वेव आहे, ती जर आली त्या पॉइंट वरती, it is going to displace that particle this much above. Okay? पहिली वेव आली तर एवढं डिस्टर्ब करणार वरती, दुसरी वेव आली तर एवढं डिस्टर्ब करणार वरती. समजा दोन्ही वेव्स एकाच वेळी त्या पॉइंट वरती पोहोचल्या, then what will happen? First wave is going to displace this much. It will bring about this much displacement. एवढी डिस्प्लेसमेंट ही वेव करणार इंडिपेंडंट ऑफ दी अदर. दुसरी वेव तिथे आली किंवा नाही जरी आली तरी पहिली वेव जी आहे तिला एवढं डिस्प्लेसमेंट करायचंय, तेवढं डिस्प्लेसमेंट ती करणार. दुसरी वेव तिला एवढं डिस्प्लेसमेंट करायचंय वरती, ती तेवढं डिस्प्लेसमेंट करणार independent of the other waves. Means what will happen at that point? The displacements will get added. So the resultant displacement will be this plus this, and the OD displacement will. So the resultant displacement will get added at that point. On the contrary, if the first wave is going to displace this much above, and the second wave is going to displace this much below. खाली displace करणार आहे. If both the waves reach there simultaneously, then there will be subtraction of the two displacements. पहिली वेव वरती डिस्प्लेस करणार आहे, दुसरी वेव खाली डिस्प्लेस करणार आहे. दोघांच्या डिस्प्लेसमेंटचं काय होईल तिथं सबट्रॅक्शन होईल, सो दॅट द रिझल्टंट डिस्प्लेसमेंट विल बी दिस डाउनवर्ड मायनस दिस अपवर्ड. तर एवढी डिस्प्लेसमेंट खाली होईल. मीन्स देर विल बी व्हेक्टर सम ऑफ द टू डिस्प्लेसमेंट्स. दोन्ही डिस्प्लेसमेंटचं काय होईल तिथं व्हेक्टर सम होईल. दॅट इज प्रिन्सिपल ऑफ सुपरपोजिशन ऑफ वेव्स. इफ two आपण दोन घेतले, they can be more than two. If two or more waves arrive at a point of a medium simultaneously, then each wave produces its own displacement independent of the others. प्रत्येक वेव तिचं डिस्प्लेसमेंट करणार जेवढं करायचंय तेवढं independent of the other. Each wave produces its own displacement independent of the others. And the resultant displacement at that point is the vector sum of displacements due to all the waves. Resultant displacement किती असणार? Vector sum of displacements due to all the waves. म्हणजे दोन्ही वेव्स किंवा तीन वेव्स जेवढे काही असतील वेव्स, डिस्प्लेसमेंट जर एकाच डायरेक्शन मध्ये करणार असतील तर सर्वांचं ऍडिशन होईल, आणि जर अपोजिट डायरेक्शन मध्ये करणार असतील तर दोघांचं सबट्रॅक्शन होईल. मीन्स देयर विल बी व्हेक्टर सम. That is principle of superposition of waves. When two or more waves arrive at a point of a medium simultaneously, एकाच वेळी, then each wave produces its own displacement independent of the others, and the resultant displacement at that point is the vector sum of displacements due to all the waves. That is principle of superposition of waves. When this superposition occurs, you cannot see that. आपल्याला दिसत नाही ते सुपरपोजिशन होताना. समजा साऊंड वेव आहे, ही वेव येते, ती आली 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 वेव, हे पहा दुसरी वेव येते, हे पहा तो पार्टिकल चालला चालला चालला. असं होतं का? नाही. यू कॅनॉट सी दॅट. व्हॉट यू कॅन डू, यू कॅन हिअर, isn't it? If it is a sound wave, जर डिस्प्लेसमेंटचं ऍडिशन झालं तर तुम्हाला मोठा आवाज ऐकू येईल. जर डिस्प्लेसमेंटचं सबट्रॅक्शन झालं तर तुम्हाला हळू आवाज ऐकू येईल. isn't it? So that effect, the physical effect of superposition is called interference. The physical effect of superposition is called interference. Physical effect means what? Physical means what? The things that you can see, that you can hear, that you can touch, that you can smell, that you can sense. That is physical effect. जे आपल्याला दिसतं किंवा ऐकू येतं किंवा ज्याचं आपल्याला सेन्सेशन होतं, ज्याला टच करता येतं, these are all physical effects. So the physical effect of superposition is called interference. So interference means if it is a sound wave, you'll hear either a loud sound or a low sound, weak sound. If it is a light wave, you'll see a bright light or you'll see dim light or no light. Constructive जर झालं म्हणजे जर डिस्प्लेसमेंटचं ऍडिशन झालं तर ब्राईट लाईट दिसेल, सबट्रॅक्शन झालं तर आपल्याला डिम लाईट दिसेल. दॅट इज कॉल्ड ॲज फिजिकल इफेक्ट, अँड दॅट फिजिकल इफेक्ट ऑफ सुपरपोजिशन इज कॉल्ड interference. Or another way you can define interference as the phenomenon of enhancement or cancellations. The phenomenon of enhancement or cancellation of displacements is called interference. Both the definitions you can use. First definition for interference, the physical effect of superposition. The physical effect of superposition is called interference. First definition. And second definition, the phenomenon of enhancement or cancellation of displacements is called interference. This interference is of two types: constructive interference and destructive interference. Suppose this is one wave, okay? Suppose it is a transverse wave. So this is the crest and this is the trough. Now suppose there is superposition of another wave on it. याच्यावरती जर दुसरी वेव आली simultaneously in such a way that the crest of one wave coincides with the crest of the other and the trough of one wave coincides with trough of the other. एका वेवच्या crest वरती दुसऱ्या वेवचा crest आला आणि एका वेवच्या trough वरती दुसऱ्या वेवचा trough आला. What will happen here? The displacements will get added. This plus this total displacement will be addition of the two. This is called constructive interference. काय म्हणतात याला? Constructive interference. When there is addition of the displacements, it is called as constructive interference. If it is light wave, you will see a bright light when there is constructive interference. And if it is sound wave, म्हणजे crest आणि troughच्या जागी compression and rarefaction जर असेल, if it is a sound wave, then where there is constructive interference, you will hear a loud sound. Suppose if the two waves arrive at a point in this manner, अशा आल्या दोन वेव्स सायमल्टेनियस एकाच वेळी आल्या दोन्ही वेव्स, but crest of one wave coincide with trough of the other and trough coincide with crest, or compression of one wave coincide with rarefaction and rarefaction coincides with compression. What will happen here? There will be subtraction of the displacements so that the resultant displacement will be this minus this. The resultant displacement here is not. This will be the resultant wave. So you will hear a sound of low intensity. कमी तीव्रतेचा आवाज तुम्हाला ऐकू येईल. We are talking about sound wave. And if it is a light wave, then you will see a dim light. Here you will see a bright light. Here you will see a dim light. This is called destructive interference. Destructive interference. So interference is of two types: constructive interference and destructive interference. When there is enhancement of displacement, addition, it is called constructive interference. When there is cancellation of displacements, it is called destructive interference. So in case of sound wave, where there is constructive interference, you'll hear a sound of high intensity, large intensity, and when there is destructive interference, you will hear a sound of low intensity. That is constructive interference and destructive interference. Now, when will there be a constructive interference and when there will be destructive interference? Constructive interference will occur when the two waves are in phase. Constructive interference will occur when the two waves are in phase. In phase means crest of one wave coincide with crest of the other and trough coincide with trough, or compression coincides with compression and rarefaction coincides with rarefaction, means they are in phase. आता crest coincides with crest. एका वेवच्या crest वरती दुसऱ्या वेवचा crest आलाय, means their phase difference is how much? 0. है ना? crest आणि crest, पहिल्या वेवचा crest दुसऱ्या वेवचा crest, phase difference किती असेल? 0. or phase difference can be 2 pi. 0 नाही तर किती असेल phase difference? 2 pi. कारण एक crest आणि दुसऱ्या crest मध्ये phase difference किती असतो? 2 pi चा. So they are in phase means we are talking about sound waves. So they are in phase means compression coincides with compression, rarefaction coincides with rarefaction, or त्याचाच दुसरा अर्थ their phase difference is either 0 or 2 pi or 4 pi or 6 pi onwards. Their phase difference is either 0 or 2 pi or 4 pi or 6 pi or 8 pi onwards. याचाच अर्थ काय? फेज डिफरन्स 2 पाय आहे म्हणजे डिस्टन्स किती? 2 पायचा फेज डिफरन्स म्हणजे डिस्टन्स असतो लॅम्बडा. सो फेज डिफरन्स इज 2 पाय मीन्स पाथ डिफरन्स is lambda. Phase difference is 2 pi means path difference is lambda. Phase difference is 0 means path difference is 0. दोन्ही वेव्स चे पाथ्स जे आहेत त्यांच्या पाथ्स मधला डिफरन्स आहे either 0 or lambda or 4 pi means 2 lambda 3 lambda onwards. So this is the meaning of in phase. Constructive interference will occur when the two waves are in phase. In phase means the crust coincide with crust and trough coincide with trough, or compression coincide with compression and rarefaction coincide with rarefaction. In phase means the phase difference is either 0 or 2 pi or 4 pi or 6 pi onwards. In phase means the path difference between the two waves is either 0 or lambda or 2 lambda or 3 lambda onwards. So you can take three meanings of in phase: crust with crust, trough with trough, or compression with compression and rarefaction with rarefaction. Second meaning, phase difference either 0, 2 pi, 4 pi, 6 pi onwards. Third meaning, path difference 0, lambda, 2 lambda, 3 lambda onwards. This is called constructive interference, where you will hear a loud sound. Destructive interference kadi will when the two waves are out of phase. Destructive interference will occur when the two waves are out of phase. Out of phase means crest of one wave coincide with trough of the other and trough coincide with crest, or compression coincide with rarefaction and rarefaction coincide with compression. Out of phase चा पहिला अर्थ. Second meaning of out of phase, their phase difference is या दोघांच्या मध्ये 0 आणि 2 पायच्या मध्ये काय? पाय. 2 पाय आणि 4 पायच्या मध्ये 3 पाय, 5 पाय, 7 पाय onwards. Out of phase means phase difference is either pi or 3 pi or 5 pi or 7 pi onwards. Pi phase difference म्हणजे path difference किती? 2 pi means lambda, so pi means lambda by 2 or 3 lambda by 2 or 5 lambda by 2 or 7 lambda by 2 onwards.